need a vertex. Okay, in order for a parabola to be a parabola, we need a vertex. Write this down, memorize it. In this form, the normal quadratic form that you're used to, the vertex is always going to be the opposite of b over 2a. They just don't tell you that, okay? The opposite of b over 2a will give you the x value of the vertex, okay? If I give you the x value of the vertex, can't you find the y from that? You can. All right, let me just walk you through it and show it to you. Okay, so the opposite of b over 2a, right? So the opposite of negative 6 over 6. So negative 6 divided by 6 is negative 1. Negative 1's opposite is a 1. Are you guys with me so far? Look all the way down at the bottom of B on page 333. What's the x value for the vertex? It's a 1. Okay? So now that I've already given you this, in order to get the rest of the information, we can actually plug this in, and I don't know if they show you that in example 4 or not. I think they do. Yeah, they do. Take your 1 and plug it in all the spots where it's x. Okay? 3 times 1 squared, which is 1, minus 6 times 1, which is 6, plus 1. 3 minus 6 is negative 3. Negative 3 plus 1 is negative 2. What's the vertex's y value? It's negative 2. Okay? So what I'm trying to tell you is the way they're showing you right here, which I am going to show you, but it's really, really cumbersome. And I feel that using the quadratic information, the opposite of b over 2a, getting your x value, plugging in your x value, 6 times 1, and solving for y, it's a whole lot easier. A whole lot easier, okay? So, let's show to you what they have, and I'm going to keep going, and I'll go back to this as well, but this is what they have. Okay, this is on page 333. They want you to rewrite the equation in y minus k, ax minus h squared form. Okay? Show that this is a parabola. Okay, here we go. Here's what you start with. Okay, the first thing we're going to do is subtract that. So now it's y minus 1, I change that to a y, equals 3x squared minus 6x. Okay, so now I'm showing you what the book is showing you in example 1. Okay, I showed you the little trick that they don't get to till 4 examples later, but I think it's important that you know that right off the top. Okay? Factor x squared so that the coefficient becomes 1, which means I can pull that 3 out. 3x squared minus 2x. Okay? Hopefully you guys remember that. Now remember when you were taught completing the square? Well, that's what we're going to do so that we can create a complete the square form. Take half the coefficient of x, which is a negative 1, square it, and add it to the right. Wait, I thought you added it to both sides, Mrs. Myers. Yes, we will. Add it to the right. Okay? You would think that you're going to add it to the left just like that as well, but you actually have to multiply it by what you factored out and add that to the left. You see why this is cumbersome and why I like the other way better? Okay, so now what you have on the left is going to be y plus 2 equals, and I could now just factor x squared minus 2x plus 1, and it'll look like this. Now I have it in what they call completing the square form, and I could again find the vertex and then go on and find more information. Okay? But if you have it in quadratic form and they ask you for the vertex, that's all you need to do. Okay, you will need to understand this because there is some more that we have to do with it, but I just wanted you to have this so that it's available to you for quick x value, to find the x value. So anyways, I now have my vertex. Which is 1, negative 2, and I solved it the way they told me to solve it. Okay, now that I find the vertex, I can go in and find more points, but I don't know if you're noticing here, they're not really making you do that anymore, as long as it kind of looks like a parabola, unless they ask you for zeros or more information. But in any case, I go over 1, down negative 2, that's my vertex. My parabola is going to go like this. If I found more points, I could find that more accurately. 1, negative 2, vertex, and negative over 1, down negative 2, and 1 is my axis. All right, that's all we're really looking for, okay, so far. So, takeaways from this, if you just need the vertex, and you have a quadratic, use this to find the x value. Take the x value, plug it into the quadratic, and it will give you the y value at that x location. Then you have your vertex. Okay? If it's in normal looking ax squared plus bx plus c form. Okay, if you don't like this, great. Go down and do all this work and get to this spot, and once you're here, you can pull out your vertex the same way. The key for this is, if you're completing the square, whatever you say, take half the coefficient, square it, and add it to this side, yes, but then you also have to multiply it by whatever you pulled out in order to add it to the left. Because this 3 is also part of what's getting combined over here to complete the square. Okay, that's why this seems so tricky. All right? All right, I'm just going to keep going. Don't stress. We've got several examples to do. We're going to do example 3 now because they're going to ask for some more information. Okay? I'm not sure how far we're going to get because this is a tough lesson, but it's mainly a continuation. Okay, they ask, and I'm just going to change it to y because that's how I always do these. 6 plus 6x minus 3x squared. They want to know the vertex, they want to know the range, they want to know the domain, and they want to know the zeros. Okay, domains are traditionally the x values. Okay, so think x values, if you remember that from olden days. The y is always what we think of as the range, okay? And the zeros are whatever would produce a zero value. And we're going to go through that. If I wrote this if I had this written in normal order, it would be negative 3x squared plus 6x plus 6, right? Because it's a x squared, b x, and c. Okay? Quick and easy. The opposite of b over 2a will give me my vertex x. You're going to have to practice this a lot and go back to the book over and over before this will start to click. Okay? Opposite of b over 2a, so negative 6 over 2 times negative 3? Negative 6 over 2 times negative 3, which negative 6 over negative 6 looks like it's a 1. Would you agree with me? Right off the bat, I know my vertex's first value is going to be a 1. Okay? So if I have my x value for my vertex, I can easily solve for my y value by plugging this x in right here. Okay? And they show you that as well. They'll tell you that they actually left it in the order that they had it, but I prefer to have it in ax squared plus bx order. So negative 3 times 1 squared, which is 1, plus 6 times 1 plus 6. negative 3 plus 6 plus 6. Looks like a positive 9, am I right? If my arithmetic's correct. That being the case, that is going to be the y of my vertex. Okay? Using opposite of b over 2a, you can find your x of your vertex, which we did. Plugging in the 1 into the original quadratic gives you your y of your vertex. Okay, so my vertex is 1, 9. My vertex is 1, 9. That answers letter A. Letter B, this is going to seem ultra silly, but it's true. No matter what I plug in for x, I can have a domain. Okay? I have not found an answer yet where the answer wasn't all. All real numbers will work. Okay? All real numbers will work. No matter what I plug in, I will get a y value. Okay? Not imaginary, but if I plug in a 1 or a 2 or a 0 or a negative 1 for that matter, I will find a domain. Okay, here's where it gets tricky. Y's range. In order to find y's range, either first you have to go and convert it by completing the square, which I think is annoying, or trick number 2, which they don't explain very well, but Khan Academy does, which is why I know it. The opposite of, or the value of A dictates the direction of the parabola, right? So positive A's go like this, negative A's go like this, right? Positive A's are up, negative A's are down. You don't have to flip anything around. You can look at it right now. As it sits, you don't have to maneuver anything. Okay? Since my A is negative, my parabola is like this. Okay, do we all know this? A is negative, so my parabola is like this. That means this value is the top of my parabola. So if I were to graph it, and I'm going to cheat here because I don't really want to count 9 spots. 1, I guess I can, 3, 4, 5, 6, 7, 8, 9. No matter what the rest of the points are, whether I'm right or wrong, this is the top of my parabola. Okay? Because A is negative, that's the top of my parabola. Vertex 1, 9. If I wanted to know my axis, x equals 1. Can y equal 10 at all? No, because if this is the top of my parabola, I can't go any higher. There are no values inserted into this equation where y will equal 10. Okay, this is going to help us answer C. What is the range? Well, y has to be less than or equal to 9, no matter what, because this is the top of my parabola. So in order for you to be able to say what the range is, you have to first know, is it a smiley face or frown, and then determine it from there. If it's a frown, the y value is the top, only y is less than or equal to will work. Okay? If it's a smiley face, the y value is the bottom. So only values greater than or equal to will work. And we'll see more like that. Okay? That's why this is the range. Okay? Zeros, this is easy. You will be totally fine with this. Okay? How will I discover what the zeros are? Well, when the output is 0. And to solve for the zeros, you're simply going to plug everything into the quadratic because the zeros are the roots. Okay? How do I find the roots? Simply use the quadratic equation. And this is the last thing. Okay, and we're going to do a lot of examples. So if you're feeling lost today, it's okay. We've got a ton of examples for these. These are very, very intricate. Okay, quadratic equation. Opposite of b plus or minus. I always have to go back and make sure I'm copying it right, guys. It's too much for me to have memorized. Let's make sure I have it right. Let's find it real quick. Opposite of b plus minus b squared minus 4ac over 2a. Okay, very good. So the quadratic. So we're going to go back to this, plug in all the numbers. A, B, and C. Okay? You guys can see it. Opposite of B. So 6 is B, negative 6, plus or minus the square root of 6 squared, which is 36, minus 4 times negative 3 times 6. All of that over 2 times negative 3. Okay? You could go through and do all that, and what you're going to find is the value of the root is 1 plus or minus the square root of 3. What does that tell us? This is actually going to be y is 0. The zeros, y is 0. So 1 plus radical 3 is here. Okay, just ignore how pretty my graph is. 1 minus the square root of 3 is here. These are your zeros, also known as where y is 0. Okay? So the fourth and final question, what are my zeros? 1 plus or minus the square root of 3. Okay? And they tell you that at the bottom. The zeros are the x-intercepts. Well, that makes sense because y must be 0 for those to be true. Okay? All right. I am going to change this a little bit because we're out of time. I'm going to have you guys do that assignment, but skip 19, 21, and 23.